Welcome back, fellow nerds. In today's video we continue with motion, and we'll look at another example to continuously cement on these concepts that we've been learning. I hope we've been learning. Okay, so right, let's look at this question. In the Daytona 500 auto race, a Ford Thunderbird and a Mercedes Benz are moving side by side, right? Side by side. Okay, so let's assume this is a Benz. Right? Yeah, not an artist. Anyway, this is a Benz. This is a Thunderbird. This is a Thunderbird. This is a Benz, right? Moving side by side, right? Side by side. Moving side by side. Okay, so they're both traveling. This is a road. Okay, both traveling. So down a straight away at 71.5 meters per second. 71.5 meters per second. This is the magnitude of their speeds, right? The driver of the Thunderbird realizes that she must make a pit stop, and she smoothly slows to a stop over a distance 250. So she's traveling a distance 250. She stops, right? She stops there. Okay, then after that, then she spends how long here? 5 seconds in the pit, and then accelerates out, reaching her previous speed. Okay, 71.5. She gets back to that speed after a distance 350 meters. Okay, at this point, how far has the Thunderbird fallen behind the Mercedes Benz, which has continued at a constant speed? How far has the Thunderbird fallen behind the Mercedes Benz? Okay, so how far is the Mercedes Benz ahead, and how far is the Thunderbird behind or fallen behind, right? That is basically the question. Now we can only know how far it has fallen behind when we know how far the Mercedes Benz is actually at. Like, where is the Mercedes Benz right about now, right? Okay, all right. So let's get to speed is equal to distance over time. This is for the what? This is for the Benz, right? This is for the Benz. Okay, the Benz, right? Okay, so we need to know at what distance is the Benz at, right? What distance is the Benz at right about now? Okay, so distance is equal to speed times time, right? We know the speed at which the Benz is traveling at, right? Because they're traveling at the same speed as the Thunderbird, right? The time, however, okay? Now, the only difference in time between the Thunderbird and the Benz was the 5 second stop that the Thunderbird made. Because if it did not make this stop, they would be traveling at the same, they were already traveling at the same speed. They would have been at the same distance if not for the Thunderbird to stop for 5 seconds, right? So we are going to assume the time it took. Okay, so we are going to assume the time it took for the travel would be the same minus the 5 seconds. Okay, how do we find that time minus the 5 seconds? All right, we can use now, again, physics. We can try to see the data that we have, right? We know the distance traveled, right? Because here we do not know the distance, we do not know the time. You cannot solve a question with two unknown variables, right? So let's see what we have. So in the Thunderbird equation, right, we have its speed, because it maintains the same speed, so speed is still intact. The distance, we have a typical distance it has traveled, right? 250, 350, right? Which is 250 plus 350, that should be 600 meters, right? This is the distance it has traveled, 600 meters, right? What's the time? Okay, This is a time for the what? This is a time for the Thunderbird, right? The time for the Thunderbird is what? The typical time variable. Like in the previous video, we talked about a typical time variable because they are traveling both in a straightaway. And so the time variable is the same, right? However, the time taken for the individual vehicles is different, okay? But the variable is the same. However, the time taken for the Thunderbird is the typical known and constant common variable minus the 5 seconds it took to rest, because in the 5 seconds it was not traveling. So these 5 seconds should be subtracted from the time it took for the Thunderbird to travel that distance, right? So what do we do then? So we get to the formula. This is for the Thunderbird, right? Thunderbird, okay. What is the speed for the Thunderbird? 71.5 meters per second. The distance for the Thunderbird is 600, right? 600 meters. The time for the Thunderbird is time minus the 5 seconds. Okay, so you have 71.5 meters per second multiplied by, because here we cross multiply, 5 seconds is equal to 600 meters. Okay, so okay, you can make your life easier by just multiplying directly from there. Okay, meters per second, you cancel. You'll have time is equal to 5 seconds. Oh, sorry, time minus 5 seconds is equal to, here there's meters, here there's meters, the s will cancel out, the meters will cancel out, sorry. And you remain with 600 divided by 71.5. That should give you 8.339. okay, so time is equal to 8.39. change sign, so the negative becomes a positive after it changes its side, right? Okay, so your time becomes 8.39 plus 5, that gives you 13.39, which we can say 13.4 seconds. Okay, this is our time variable. Okay, and as such we can go replace this time variable in the equation. Okay, this equation, right, for the Mercedes Benz. Okay, where distance is equal to speed times time. Okay, because the time variable is the same as that of the Mercedes Benz. So the distance that the Mercedes Benz is at right now, traveling at this speed, meters per second, multiplied by that time. Okay, the distance would be, so 71.5 multiplied by 13.4. The distance is 958.1, so we can just say 958 meters. Like I said, 3 significant figures. So 958 meters, this is a distance the Mercedes Benz was at that time. However, the question is a bit specific. It's saying how far behind, right? So how far behind? We have to give some sort of you have to say I am 5 meters behind, I am 4 meters ahead. You know, the difference between the individual distance should give us a distance difference between the two vehicles, right? All right, so this distance is for the Benz, right, for the Mercedes Benz, right? Okay, so where is the Thunderbird now? Where is the Thunderbird now, right? So the Thunderbird is at 600 meters. We found that in the earlier, right? So we say 958 minus 600 meters, right? That is 958 minus 600. That gives you what, 358 meters, right? 358 meters was how far the Thunderbird was behind. So the Thunderbird was okay, so you can write this as your Thunderbird. Oh, it's not yours. Where till you buy yours, right? Your Thunderbird Ford. Your Ford was say was 358 meters behind the Benz, right? Behind the Benz. Okay. However, the distance the Benz was at was 958, and this is what has helped us find the difference between the two vehicles. This is how far the Benz was ahead of the Ford by 358 meters, and the Ford as wise was had fallen behind 358 meters from the Benz. Okay, so the Ford is that the Ford was 358 behind the Benz. That is your answer. All right, so I hope we have learned again. We have learned, I hope, something in this question. And as wise, if you've learned something, do share, so we can all learn, right? All learn. Thank you so much. We'll meet in the next video.